All right, I'm going to start the key now, and then I'm going to have to finish it later, but you're not going to know that there's any time difference, unless I sound super different. All right, Mrs. Key. What values of function is f of x continuous at -3? All right, so at -3, in order for us to be continuous, we need the limit as x goes to -3 from the left to equal the limit as x goes to -3 from the right to equal f of -3. So we need all those things to be true. So let's see. The limit from the left comes from this piece. So that piece is, if I plug in -3, that'll be 18 minus, so that'll be 6. Equals, the function value is k squared minus 5k. Just for fun, the limit from the right is also 6. So these are equal, so we've got that part down. Now we just have to figure out what k value, or k values, will make this happen. So what if I say k squared minus 5k minus 6 equals 0? And factor, k minus 6, k plus 1. So that means k is going to be 6 or -1. Both those will make my function continuous. Let f be the function given by that. Which of the following statements about f are true? F is continuous at 0. Well, absolute value of x looks like this. So most, oops, I missed a little bit, but whatever. So yes, continuous. Differentiable? Heck no. Absolute minimum. Don't know what that means, but I think it has a really low point there, so sounds good. 1 and 3. Beautiful. I do know what absolute minimum means. Shh, don't tell anyone. Let f be the function defined by that. Which of the following statements is true? So f of x square root absolute value x minus 2. So if it's just the square root of x minus 2, that looks like this. But the square root of the absolute value means it'll look like this. So we'll have some sort of, I like to think of it as a little birdie thing going on right there. So that means, yes, we are continuous, but we are not differentiable. So we're not differentiable. We are continuous. The limit as we go to 2 does equal 0. And we do not have a vertical asymptote there. So A is my answer. Now on the quiz, make sure you justify each of those pieces. I just did it verbally. Make sure you justify each of those pieces. Explain why we're not differentiable. The reason is the slopes are different coming in and out. Explain why we are continuous. The reason we're continuous is because the limit from the left equals the limit from the right equals the function value. Explain why the limit is 0. And explain why we don't have a vertical asymptote there. So make sure your explanations are good.
Next up, we got derivatives based on definition of derivatives. And first off, we're going to have the function f of x is equal to x cubed minus 3x. And we've got a second function, g of x, which is negative 4x squared plus 3x. We've got to find the slope of the secant line on the interval from 1 to 6. That's basically plugging in 1 and 6 to each of these. You can see what we get for y values. So if I do f of 1, I'm going to actually zoom in to make this much bigger and leave me with way more room. So f of 1 is going to be 1 minus 3, which is negative 2. And f of 6 is going to be 216 minus 18, which is 198. Okay, so we're doing slope here, so it's going to be 198 minus negative 2, divided by 6 minus 1, which is going to be 200 over 5, which is 40. For the other one, g of x, we're looking at from 1 to 6. G of 1 is going to be negative 4 plus 3, which is negative 1. And g of 6 is going to be negative 4 times 36 is going to be negative 144 plus 18, which is going to be somewhere on the order of negative 134 plus 8 is negative 126. Our slope here would be negative 126 minus negative 1 over 6 minus 1. So negative 125 over 5, which is going to be negative 25. Okay. We've got to find the slope of the tangent line when x equals 1 using the definition of derivative. Which I think might be slightly different than... No, it's the same order. On the spiral itself, I changed the order of these because it makes more sense going the other way. I'll do one of these each way. The first I'll do as a normal definition derivative. The second I'll do the alternative form. So for the definition derivative, we know we're taking the limit as h approaches 0 of f of x plus h minus f of x, and divide that by h. Okay, f of x plus h. So we're looking at h approaches 0. That's going to be x plus h cubed minus 3 times x plus h. And that's going to be minus x cubed plus 3x, all divided by h. And looking at this, x plus h cubed, when you multiply it out, is going to end up being x cubed plus 3x squared h plus 3xh squared plus h cubed minus 3x minus 3h minus x cubed plus 3x. And I notice that x cubed and my 3x's will cancel out. All this is divided by h. We're going to rewrite this with everything with one h removed. And the limit, h approaches 0. And that's going to be of 3x squared, that h is gone, plus 3xh plus h squared, and then minus 3. I divide all of those by h because we've got an h in that denominator. And when I plug h equals 0 in, I get 3x squared minus 3, which, based on knowing power rule, we should have known. So then at x equals 1, 3x squared is going to be 3 minus 3 is going to be 0. For the other one, I'll do the alternative definition for a derivative at a point. And that's going to be the limit as x approaches a, in this case that's 1, of g of x minus g of 1 over x minus 1. So let's plug this in. So the limit is x approaches 1, and that's going to be negative 4x squared plus 3x. And then at 1, that's going to be negative 1. And that's going to be over x minus 1. I'm also going to factor a negative out of the top, just so I can factor this nicer. And that's going to make this be 4x squared plus 3x, 4x squared minus 3x minus 1. Okay. I know that this is going to factor, because when I plug 1 in, I get 0 over 0. And if I think about this, that means that one of the things up top has to be x minus 1. And to get 4x squared, this has got to be 4x. And to get a minus 1, it's got to be a plus 1. And just to kind of make sure, we got 4x squared plus x minus 4x is negative 3x. Cool. Minus 1, we are golden. Things cancel out. Plug in 1, and I get negative 5 as my answer. We've already done part C as part of part B. That's what we did here, 3x squared minus 3x. And that's why I, on the spiral, put that part first, so you can use the definition first. If you're asked to use the definition, you have to use it. You cannot use a power rule in order to do this problem.
Equation of the line tangent to the graph. So I need a point. They give me a point, so I need a slope. To find the slope, I find the derivative. So y prime, or dy dx, is the derivative of the top, which is 2, times the bottom, minus the top, times the derivative of the bottom, all over the bottom, squared. Now I'm looking at a specific point. So I'm plugging in 1 right away. So y prime at x equals 1 is going to be 2 times 3 minus 2 is 1, minus 2 plus 3 is 5 times 3, all over 3 minus 2 is 1, so 1 squared. 1 squared is obviously 2, right? So 2 minus 15, I'm just kidding. 1 squared is not that. So the slope is negative 13. Now, these equations are in standard form. So y equals the y value minus the slope x minus the x value. So that's going to be y equals 5 minus 13x plus 13. So that equals 18, so I pick this one. Now, we were also asked, if I shrink this, about 1 over x plus 3. I'll address that on the next page here. Next one, the approximate value of y equals that at that obtained from the line tangent. For a tangent line, you need a point and a slope. I'm going to get the point. I know the x value is 0. Plug in 0 for x. Sine of 0 is 0. Plus 4 is 4. Square root of 4 is 2. So the point is 0, 2. And I need a slope. To find the slope, I find the derivative. dy dx equals, think of this as not the square root, but to the 1/2. So it's 1/2, 4 plus sine x to the negative 1/2. And now we plug in. So dy dx, when x equals 0, it's going to be 1/2, and then 4 plus 0 to the negative 1/2, which is 1/2. 4 to the 1/2 is 2. 2 to the negative 1 is 1/2. Half times a half is a quarter. So that means my tangent line is y equals the y value plus the slope, x minus the x value. Now they want us to know at 0.12. So at 0.12, I plug in 0.12 for x. So 0.12 times a quarter is 0.03, so 2.03 would be my answer. This has approximate value. Don't use a calculator and try to find the specific value, because that's not what they're asking us for. They're asking us write the tangent line, find the approximate value. Next one. Now I'm not going to look at it like that. Cosine of 3x squared. And if you want to put in some extra parentheses, you can see outer function, first inner, second inner. So that means my derivative is going to be, the 2 comes down, leave the inside alone, leave it, leave it, leave it, leave it, leave it. Now I touch the cosine. Derivative of the cosine is the negative sign, leave the inside alone, leave it, leave it, leave it. There's a negative there. Now I touch the 3x, sorry. Derivative of 3x is 3, and I'm done. So that's negative 6 sine cosine. Got it. This means the second derivative. So the second derivative would be, I would do it again. So if this is my first derivative, I would do product rule. So d squared y dx squared. Second derivative. Derivative of the first, negative 6. Derivative of sine is cosine 3x. Chain rule times 3, and then cosine 3x. Plus negative 6 sine 3x. Derivative of the cosine is the negative sign. Leave the inside times 3. That would be your second derivative, which we could clean up, but I'm not going to. Next one, implicit differentiation. All right. The key to implicit differentiation for our purposes is if you see a y, if you take a derivative of y, make sure you put its derivative there because of chain rule. Whenever you see an xy, that is a product. Could be 8xy, doesn't matter. X and y are attached to each other. If you need to, rewrite the problem. Say x squared plus x times y plus y cubed. Because then you've emphasized that there's a multiplication there. So your derivative is going to be 2x. Derivative of the first is 1 times y plus x times the derivative of the second. I'm going to write dy dx just to emphasize the point. So derivative of y cubed is 3y squared dy dx. X dy dx plus 3y squared dy dx. Hey, I tried to write dx dy. Oopsies. Subtract the 2x, subtract the y, and then I'm going to factor off the dy dx, and I'll have an x plus 3y squared, so negative 2x minus y over x plus 3y squared. I don't see that answer here, but I see this one, which has a negative in front, which is the answer.
For number 8/24, we're looking at if sine of, I need to actually write here, if sine of x is equal to e to the y, and we're looking for between 0 and pi, that's probably just to do a limitation for domain. We've got to find dy dx. Cool. Okay, and that means I know I'm looking for y prime and get y prime by itself. Taking the derivative of both sides, we're going to have cosine of x, and the derivative of e to the stuff is e to the stuff times the derivative of stuff, dy dx, or just y prime if you prefer. To get this by itself, we just want this in terms of x. That's interesting. So we have to do some other stuff. But generally, I'd be saying this would be divided by e to the y. But I don't see that answer here. Oh, no. So maybe instead at the beginning of trying to take the derivative immediately and doing this implicitly, what if we converted this to log form? So that would be ln of sine x is equal to y. And that's a much more pleasant thing. The derivative of this whole thing, so that'd be y prime. That's what we want. Ln of stuff would be 1 over stuff. So that'd be 1 over sine x multiplied by the derivative of sine x, and the derivative of sine x is cosine x. So we get cosine x over sine x. And that happens to be the same as cotangent of x. So cotangent of x is equal to y prime. That came out really nicely when we did some log stuff first. In our last problem, we've got y is equal to ln of x divided by x. And we've got to find dy dx. In other words, taking the derivative. This is going to be a quotient rule, and I am so excited. I know this is my bottom function, my top function. So that the derivative would be the bottom multiplied by the derivative of the top, which is 1 over x, minus the top, ln of x, times the derivative of the bottom, which is 1, and over the bottom squared, x squared. Simplifying some stuff, we've got x times 1 over x, which is 1, minus ln of x. That's over x squared. That looks like that's answer D for us. And we're done.